Hello everybody. Today we will solve Leetcode problem 242 valid anagram. In this problem we are given two strings S and T and we have to return true if they both are anagrams of each other. So what is an anagram? A string is an anagram of some other string if it can be formed by rearranging the letters of that other string. For example, cat is an anagram of act and vice versa because these both can be formed by rearranging its letters. You swap A and C, you'll get cat, and you swap C and A in cat, you'll get act. And other examples are rescue, secure, listen, silent, cheater, teacher. So if you rearrange the letters in any of the strings, you can get the other string, which makes them anagrams. So in a problem, we are given strings, two strings, and we have to return true if they are anagrams, and we have to return false if they are not. So in the first example, is Nagaram and anagram uh, anagrams? So yes, they are, because if we swap A with N and A with G, we'll get Nagaram. And same with Nagaram. If we swap A with N and A with G, we'll get anagram. If the second example is car, an anagram of rat, no, it isn't, because to form rat, you'll need a T, and there's no T in car. So that's why here our output is false. Let's have a look at the constraints. Both of our strings, length of both of our strings will range between 1 and 50,000, 5 into 10 to the power of 4. And both S and T will consist of lowercase English letters. Okay, so the very first, a simple approach to solve this problem would be to sort both the strings and compare if they are identical or not. Because the way we defined anagrams, they are just different rearrangement of same set of characters. So if once both the strings are sorted, order of both the strings is consistent that of our alphabet, and if the numbers and characters in both those strings were equal, their ordered version should be identical. And if they are, we return true. If they are not, we return false. For example, if S is anagram and T is nagaram, after sorting, T will be, S would look something like this, and T would also look something like this. Both are identical, so nagaram and anagram are anagrams. Car and T again. Car and rat, if you sort them, clearly they are not identical. So in this case, we'll return false. It's quite, I mean, observation is quite simple and solution is also quite simple. Time complexity of this approach will be O of ls plus ls log ls plus lt log lt, where ls is length of s and lt is length of string t. Space complexity would be O of 1 because we are not taking any extra space. Everything is happening in place. But can we do better with time or space? Yes, we can. We can surely do better with time and without taking much of extra space. So the second approach is to use a map. What we'll do in this approach, let's write our example. Let's write a definition over here. Our definition was that both these strings should contain same characters both of these strings should contain same characters with same frequency. So that's what we'll use a map for, to check if if characters and frequency both are identical or not. So we'll initialize a map, we'll traverse a string s and increment its value in the map as we encounter it. M map a plus plus map n plus plus, again map a plus plus, and so on. At the end, our map would look something like this. A N G R M A3 N1 G1 R1 and M1. Then what we'll do is we'll traverse our second string, but this time instead of incrementing, we'll decrement. So for example, first we'll encounter an n, so we'll decrement its value in the map. Then a, then g, and so on. So at the end, what we're trying to do is, if both the strings contain same characters and those characters were present with same frequency, our map, this would mean that at the end our map should be empty. because yes, we increment when we traversed our first when we traversed our first string, we incremented everything, we added everything into our map, but when we traversed the second string, we took away everything. So if both of these strings had same characters and in same quantity, everything which was inserted into the map should be should have been taken out of the map when we traverse the second string. I hope this is clear. And if any of the character is present in the map whose frequency is not 0, greater than 0 or less than 0, then we can conclude that the string was not those strings were not anagrams. I'll show you a small example. For example, act and cat. After first traversal, our map would look something like this: A1, C1, C1, T1. And when we'll encounter C in cat, this C will become 0, this A will become 0, and then again this T will become 0. Our map is empty. If our strings were car and cat, in that case, first our map would look something like this. After first traversal, our map would look something like this. And after second traversal, A and C will be cancelled. R will remain as it is. T will be added, but its value will be -1. So our map is non-empty, which means that our initial strings were not anagrams. So this is our approach. I hope it's clear. Time complexity here is O of ls plus lt, because we are traversing both the strings s and t, and decrement operation increment decrement operation take O1 of time, O1 average time in a map, in a hash map. Space complexity will be O of 26, which is still constant time, and you can say it's O1, O of 1. Why is it O of 26? Because at max, because it is mentioned in the constraints that both of the string will consist of lowercase English letters. So there are 26 lowercase English letters from A to Z, and our map will not contain, so the keys in our map will range between A to Z. So the max size of our map will not exceed 26. So that's why our space complexity will be O of 26. Okay, so let me code this for you. Let me show you the code. Storing the lengths of these variable for convenience. I mean, if ls is not equal to lt, there is no way they can be anagrams, can they? So we'll straight away return false. If they are equal, we'll move ahead with our further checks. We'll declare a map. Which maps character to integer values, and first for the first string will increment, and for the second string will decrement. If any of the characters has a non-zero value, will return false. After checking for each character, if we are able to get out of the loop, that means our initial strings were anagrams and we can return true. Yes, let's try to submit it. Yes, it works. Okay, that's all. Thank you. See you in the next video. Bye.